With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So here we have a question. We have two statements. We have to check which statement is correct and which statement is wrong. Okay. So first of all, let me read the second statement. Statement 2 says that the differentiation of the integral with respect to x, and integral is theta x to psi x ft dt is given by first derivative of psi x and f psi x minus first derivative of theta x into f of theta x. Okay, let's check whether this statement 2 is correct or not. So I'm telling you that the statement 2 is absolutely correct because we know the Leibniz rule. Okay, so Leibniz rule, or you can say the Leibniz theorem for the integral, it is given by when we have differentiation of with respect to x any integral which is limit from gx to hx, let's suppose, and we have the function like ft dt, then this complete thing means the differentiation of the integration will be given by, you can see here clearly, it is given by f of hx. Basically I'm putting the hx means the upper limit in place of t means the variable, okay, and into the differentiation of this limit which is h dash x minus, okay, minus f of, in place of t I'm putting the lower limit, it is g of x, and the differentiation of the same which is g dash x. Okay, so this is the simple Leibniz rule we already know, and if you compare this thing with this, then you can say that by the definition of the Leibniz rule you can say that my statement 2 is absolutely correct because we have here psi x in place of t, and then the differentiation of psi x minus theta x in place of t, then the differentiation of theta x, so it is absolutely correct. Okay, so statement 2 is correct. Now I'm going to apply the Leibniz rule to see whether this thing is correct or not. Okay, so I'm writing here my statement 2, sorry, statement 1 is, here I'm going to apply the Leibniz rule for the both integrals, this integral and this integral. Okay, so for this integral I'm going to apply this formula, or you can say the rule. So it will be given by, I'm saying it as my I. Okay, so it will be given by differentiation of this integral. Let me write this thing. So it is basically differentiation of with respect to x, integration 0 to sine square x sine inverse under root t dt, okay, and plus differentiation with respect to x 0 to cos square x, here we have cos inverse root t dt equals to the differentiation of pi by 4, it is 0. Hope you already know the differentiation of constant as 0. Okay, so here I'm going to differentiate this thing by using the Leibniz rule, okay, which is more interesting that differentiating the integral. So it will be given by sine inverse of under root sine square x, because in place of t we have to write this thing. Okay, now the differentiation of the same means the limit differentiation, so it is basically 2 sine x, the differentiation of sine square x is 2 sine x into cos x. Hope you already know this thing, minus I'm going to put this limit over here, so it will be sine inverse under root 0, and 0 differentiation is simply 0, so it will be completely 0, but I'm still writing so that you can see here clearly. Okay, now same thing over here, Leibniz rule I'm applying, it will be cos inverse under the root cos square x, then the differentiation of cos square x, it is 2 cos x minus sine, means in the multiplication minus sine x, because the differentiation of cos x is minus sine x, minus I'm going to put this lower limit in place of t, so it will be cos inverse under root 0 into 0, because the differentiation of 0 is 0 simply. Okay, now moving further, first I'm going to write this thing in the simpler manner, it is equals to 0. Okay, so it will be given by sine inverse, I'm solving this thing, so this square will cancel out this root, it will be simply sine x, okay, and into 2 sine x cos x, it will be sine 2x minus, here sine inverse 0 into 0, it will be 0, cos inverse cos square x, this square will cancel out this root, this minus outside, plus minus become minus, it will be cos inverse cos x sine 2x and plus minus 0, it is equals to 0. Okay, now I'm taking my sine 2x common, so sine 2x common, it is sine inverse x, sorry, sine x minus cos inverse cos x, it is equals to 0. Okay, now here we know that sine inverse sine x is given by x minus cos inverse cos x, it is x, and here we have sine 2x and it is equals to 0. From both sides you can say 0 is equals to 0. So yeah, we can say that the given statement is correct because LHS is equals to RHS. Here we can see clearly. Okay, LHS equals to RHS means the given statement is correct. So our statement 1 is also correct. So our first option, which is statement 1, is true, and statement 2 is the true, and statement 2 is the correct explanation for statement 1. This is the absolutely correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.